This video demonstrates how to apply Johnson's rule or sequencing n jobs on two machines or two operations. The data I'm using to demonstrate Johnson's rule is from 15.18 at the end of chapter 15. We have here, it looks like 6 jobs, A through F, and there are two processes that, or two operations that each of these jobs have to go through. The first one is they need to be sanded and then painted. And so there is an order to the operations. This is operation 1 and this is operation 2. And so Johnson rule looks at what are we going to schedule first in regards to sanding. And then based on that, when it's done with sanding, it will automatically go with painting. But the idea behind Johnson's rule is to basically sequence these jobs in regards to the sanding so that they can immediately go to the painting and there's very little idle time in between. We're not waiting for something to be done being sanded before it goes to painting. And so Johnson rule is pretty simple. What you do is you look for the lowest time. These are in hours. And the lowest time for both operations is right now 2 hours for E, and it is associated with the first operation. And so what that means is that we want to put E in the first slot. If the 2 was associated with the second operation, we would have put it in the back line. So I basically have to determine how I'm going to schedule these 6 jobs, and so I have these 6 boxes here. And remember, this is the schedule for the first machine, because when they're done with the first machine, they'll automatically go to the second machine or the second operation. And since this 2 was associated with the first operation, E goes to the beginning, and E is assigned, and so we're done with E. So we could actually, I guess, just color code that in to let us know that we're done with it. We then look for the next smallest. Now we have a kind of a tie here. You got 3 and 3. Now the beauty of it is they're associated with different operations. So we're going to put D at the beginning here, and we're going to put F at the end here. So even though they're tied, we can break the tie because in this case the 3 is associated with the first operation, but in F the 3 is associated with the second operation. So here's a good example. Now if they were both associated with the first operation, then they could go in either order. We could have had DF or FD. But in this case we didn't have to make that decision because one was associated with the first operation and the second was associated with the second operation. So we've taken care of these 2 jobs and assigned those. Next smallest amount is B. It's associated 4, and so it's associated with the second, so it goes towards the back. So this will become B. That takes care of that one. And then once again we have the tie here, but the nice thing about it is 5 is C would go here and A would go here. Now in your homework problem, so what we're going to do is we're going to send job E to sanding, and then it'll go to painting, and then D will go to sanding and then painting. So painting will follow after these are done with sanding. So we're basically assigning these jobs to the first process, and then they automatically go to the second. But they want to show you how Johnson rule, and you have to do this on your homework. What I've done here is basically what I'm going to do here is we're going to keep track of these and make a timeline. So painting, and sanding. You'll notice that I made the columns really small here because I want each column, each cell to represent an hour. So let's go back to our assignments here. And so we're going to send E first. So E is going to be in Oh, I put those in the wrong order. Sanding on top, because we go to sanding first and then painting second. So we're going to send E to sanding, and it's going to be there for 2. So let's shade this in or something to that effect. We will, let's just alternate between colors. So we'll do blue, and then we'll do red. And so we know that this is E. I guess we can put an E there too to remind us that's E. And then after it's done, it's going to go to painting. So there will be a little bit of idle time here. This white here, painting will be waiting a couple hours. But then when it's done, so now it's going to go here, and it's in painting for 6 hours. So 1, 2, 3, 4, 5, 6. And so let's shade that blue, and we'll note that here as an E. Sanding, so once we were done with the sanding, then it goes to D. So D is there for 3 hours. So in sanding, and so let's use a slightly different color here just so we can kind of keep these straight. And this will be D here. And then we're going to go, so D, once it's done, it'll go here to painting, and D is 8. 4, 5, 6, 7, 8. And that is D. C will then go, and C is 5 in sanding. And then it goes to 7 here. I'm just double checking my counts here. We're then at A. A is 10 for sanding. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see what colors haven't we used. We'll use an orange there. That'll become A. And then it goes here for 5. 1, 2, 3. A. B is 7 in sanding. 1, 2, 3, 4, 5, 6, 7. Let's use a gray. It'll be B, and then it goes here to, let's see, I'm going to reduce this down a little bit so I can keep everything on the screen there. B was sanding, then it's 4 here for painting. B, and then the last one, F, was 4 for sanding. 1, 2, 3, 4. One more color, we'll use a green. And this is going to be F. And then this will be F. Oops. F. So the nice thing about Johnson's rule that you'll see here in the diagram is that you know, we've basically, sanding can go, you know, start with E and then D, C, A. And I guess that's not the biggest question. The biggest question is that when they're done with sanding, there's no delay. Painting can start immediately, and work on painting, and D will be done, and so then there's no idle time. The only idle time is right at the beginning. Painting has to wait these 2 hours, and then their book. So there's very little. If you were just to randomly assign these to sanding, what would happen is like there would be a huge idle time here, and then sometimes sanding would be behind painting, and then painting would be done with what they were doing, and there would be idle time in the middle. But by doing Johnson rule, where we put the shortest times associated with sanding towards the front and the shortest times associated with painting towards the back, you basically push all the idle time out to the edges here, and eliminate any idle time in the middle here. So this is a very efficient way of scheduling your jobs, and that's the Johnson's rule.